Hello, my name is Selina Lowe. I'm the Director of Learning for STEM here at Abbot Bain School. At Abbot Bain, we have a really good set of 3 science A-levels that are always well taken. The first of the 3 I'm going to talk about is biology. And A-level biology is a broad, extremely interesting choice of A-level. The assumption is that of the 3 sciences, it is the easiest. This is not the case, but it certainly is most enjoyable and really fulfilling. Throughout year 12 and 13, topics are taught that cover both breadth and depth. This is how the exams are delivered at the end of the course. A 2.5-hour exam of each breadth and depth areas, and then a unified exam, which is 1.5 hours, and this can be from any of the areas. You will start in year 12 with the foundations in biology, building upon what you learnt at GCSE in topics such as cell structure, enzymes, cell division and cellular organisation, to name but a few. When looking at topics such as transport, you will carry out many practicals looking at the internal workings of both plants and animals. Ecology also plays a large practical part, and opportunities to carry out ecological studies in the environment will take place within Module 4. The practical endorsement part of the course is interleaved with the teaching modules, and although there are 12 required practicals to carry out, these are not graded but examined in the 3 end of course exams. The most successful students need to work consistently throughout the 2 years, with the ability to work independently using their own initiative. An A-level in biology can lead to a wide range of career pathways. This includes medicine, as well as biological sciences, ecology and the like. A-level chemistry is an interesting, complex and challenging subject. It covers a wide range of topics over the 2 years in all 3 of the chemistry areas and disciplines. There is physical, organic and inorganic chemistry. In year 12, students revisit areas such as atomic structure, mole calculations, bonding and build further from their GCSE studies. We then look at the energy and kinetics of reactions and the science ingrained into these principles, for example, Le Chatelier. In the organic discipline, we look at hydrocarbons and their formation and uses, and start to look at the reaction mechanisms and how we use technology to identify them. Inorganic chemistry is everything about the periodic table that is not carbon, and how the structure of the table helps us understand how elements meet and react. In year 13, we build further on the year 12 topics. In physical chemistry, the mathematical prowess of a student comes to play. Using a variety of calculation methods to work out the rate of a chemical change, the equilibrium constants in concentration and pressure reactions, pH calculations, and the electron movements in electrolysis. Organic chemistry delves deeply into various molecules that make up such things as plastics, DNA, proteins, perfumes, and chemotherapy drugs, to name but a few. The spectroscopy in a suitcase team come in to talk about the use of technology that students will go on to use at degree level in organic analysis, and the students' aspirin practical that they have carried out as part of the course is analysed for its purity, a great way to show how these 2 things are implemented together. The inorganic element looks at the various uses of transition metals in things such as cancer treatment, catalytic converters in cars and green energy, and how colours are produced for the various industrial uses and processes. There are 12 required practicals. As mentioned earlier, aspirin. Within these, mark students' work in areas such as following instructions, using the equipment appropriately, identifying various variables, and as well as the analysis of all of these. Having a chemistry A-level opens a plethora of doors for students' future. Medicine has chemistry as a prerequisite, along with other STEM subjects. A-level chemistry, often in conjunction with other science A-levels, can lead to a variety of different degrees. You could do a degree apprenticeship route, or you could choose to do a traditional degree route. Biochemical sciences, biochemistry, chemical engineering, dentistry, dietetics, earth sciences, environmental sciences, to name but a few. A-level physics is an exciting and challenging subject that delves into the understanding of the fundamental structure of the universe. Quantum physics is explored when studying particle physics, which leads to an appreciation of the work going on in particle colliders such as CERN. Students learn how physicists are testing the standard made by investigating the forces and fundamental particles called quarks that make up protons and neutrons. Ideas in classical and quantum physics are developed in detail, such as in the investigation of waves, mechanics, electricity, fields and nuclear physics. A-level physicists have the choice between astrophysics and medical physics as a module in Year 13. It can be decided by the needs and passions of the students for their future studies. Practical work is a core part of the course, and students will conduct many investigations, again relating to waves, electricity, quantum phenomena, mechanics and radioactive decay. Having a physics A-level shows that a student has an excellent grasp of mathematics, can approach puzzles and problems with a practical, methodical and scientific mindset, and has a deep understanding of the fundamental structure of nature that is important in all the science disciplines. So, as I said earlier, we have a really good uptake in all three of our science A-levels here at Abbot Baines School. Our students go on into medicine, and we've had students go into medicine every year for many years now. They go into engineering, and some of them even decide to do things like forensic science. But the mainstay of this is that our students enjoy science, and we make it as fun and interesting as we possibly can.